Hello, welcome to Booksmart. I'm Ryna, and today I am going to be walking through a big chunk of a quant section of a GRE test, and we are going to look at all the problems that are not quantitative comparison. You can look at me going through the same test, but just the quant comparison problems in another video that I've made that I'll link in the description. So let's get right into it. Follow along with me as I show you how I do these problems on the test. All right, question 10. We are given these two equations, 7x plus 3y equals 12 and 3x plus 7y equals 6, and the question says, if x and y satisfy the system of equations shown, what is the value of x minus y? So the traditional way that you would solve this problem would be to solve for x, solve for y, and then subtract. But there's actually a much faster way here, which I can just subtract the two equations. 7x minus 3x is 4x. 3y minus 7y is negative 4x. And then 12 minus 6 is 6. And I can factor out a 4. Ooh, I wrote y. This is x. This is supposed to be y. So 4 times x minus y equals 6. That means x minus y equals 6 fourths or 3 halves. So our answer is B. Next question. This one is a select all that apply. So that means there could be more than one answer. In the triangle ABC, the measure of angle A is 25 degrees and the measure of angle B is greater than 90 degrees. Which of the following could be the measure of angle C? So with a problem like this, I like to find a range of what B could be and what therefore C could be, and I'll choose all values or answer choices that fit that range. So A is 25, we know. B is greater than 90, so that means B is greater than 90, and to figure out what B has to be less than, I'm going to take the measure of the sum of the total of the interior angles of a triangle, 180, subtract 25 because we know A is 25. So if we do 180 minus 25, we get 155. So B has to be less than 155, so we have room for a third angle, and it's greater than 90. All right, so the way I'm going to figure out what C is, C has to be at least 1 degree, right? Because we know that there's a third angle, so it has to be at least 1. And if B were 90, we're left with 65. So C has to be somewhere between 65 degrees and 1 degree. And then I'm just going to go ahead and choose every answer choice that is in that range. So it is A, B, C, and D. Okay, next question, question 12. What is the least integer n such that 1 over 2 to the n is less than 0.001? I think that the way I would approach this is to take a look at the answer choices and start with those. Instead of just solving for n, I can just look and see that A is our smallest answer choice. So if that works, that should be our answer. So let's plug it in and see what happens. 1 over 2 to the 10th is less than 0.001, and 2 to the 10th equals 1024. This is something you can either do in your calculator or, kind of mentally. 2 to the 3rd is 8, and so then 2 to the 4th is going to be 8 times 2, 16, and I can keep going from there. It's pretty easy to do 2 to some exponent. So 1024. So that means that 1 over 1024 is less than 0.001. And again, in the calculator, we could see that 1 over 1024 is 0.0009. And 0.009 is less than 0.001. And so that means A is our answer. But I just want to think about a few, the biggest thing that I would think about is because I see that E, there's no such least value. So I just want to confirm that 10 actually is the smallest possible integer that n could be to make this statement true. So I know that as n is going to get bigger, the 1 over 2 to the n gets smaller and smaller and smaller. So, and that's because it's a fraction, right? So as the denominator of a fraction gets bigger, the fraction overall becomes a smaller number. So to see if we can go smaller than n equals 10, I'm going to try what happens if I do n equals 2. Let's just kind of go pretty small and see what happens there. So 1 over 2 squared is 1 to the 4th, which is 0.25, right? And that is clearly larger than 0.001. So that doesn't work. Okay, n equals 9. So n equals 9 is the integer right below 10. So if we say that 10 is the least, 9 would be the next one to check to make sure that this is true. So 1 over 2 to the 9th is 2 to the 9th is 1024 divided by 2, meaning 512. So 1 over 512. And in my calculator, when I put that in, I see that is 0.00195 and more numbers after that. 0.00195 is bigger than 0.001, and so that is clear. N cannot equal 9 because that doesn't make this statement true, but n equals 10 is the smallest integer that makes it true. 13. In the sunshine, an upright pole 12 feet tall is casting a shadow 8 feet long. So our pole is 12 feet tall and it's casting a shadow that's 8 feet long. Ignore the drawing because that doesn't look quite proportional, but you get the idea. At the same time, a nearby upright pole is casting a shadow 10 feet long. Okay, here's our other pole with the 10-foot long shadow and our unknown pole length. If the lengths of the shadows are proportional to the heights of the poles, what's the height in feet of the taller pole? So this is just a simple proportion I'm going to set up. X over 10 equals 12 over 8. 8x equals 120, and x equals 15, so our answer is D. Pretty straightforward. All right, 14. If A is the smallest prime number greater than 21, and B is the largest prime number less than 16, then A times B equals. So we have to figure out what is the smallest prime number greater than 21. 21 is not a prime number, 22 is not a prime number, 23 is a prime number. So A has to equal 23. B is the largest prime number less than 16. So let's go backwards from 16. 15, not a prime number. 14, not a prime number. 13 is a prime number, so B equals 13. And then we just do 23 times 13, which is 299. And A is our answer. Here we have a numeric entry problem. The total amount of Judy's water bill for the last quarter of the year was $40.50. The bill consisted of a fixed charge of $13.50 plus a charge of $0.0075 per gallon for the water used in the quarter. For how many gallons of water was Judy charged for the quarter? So this is a very simple equation that we can set up. We know $40.50 equals $13.50, which is the fixed cost, plus our cost per gallon times our unknown, which is we can call X here, and then we just solve for X. So X, this is pretty quick, is 3,600, and that's what I would write in the numeric entry. There we go, 3,600 gallons of water. We have two lists that we're given, list R and list S, and then the question says the median of the numbers in list R is how much greater than the median of the numbers in list S. So let's find the median. And to do that, we need to put our numbers in numerical order. So I'm going to rewrite list R above, 23, 25, 27, 28, 30. And our median is going to be that number that's in the middle, 27. Okay, so the median of list R is 27. And then let's do list S, put it in order. We have 15, 17, 19, 20, 22, and our median is 19. So simply 27 minus 19 is going to be our answer, which is 8, and that is A. All right, next we have our data problems, and this is the graph that we're given. So the 2 corporate sectors that increased their support for the arts from 1988 to 1991 made a total contribution in 1991 of approximately how many millions of dollars? So the graph gives us the total for 1988 and the total for 1991. And first we have to find the 2 corporate sectors that increased their support. So presumably there will only be 2. I see financial increased, services increased, and then manufacturing, retail, wholesale, and other all decreased their support. So we know we're looking at financial and services. What was their total contribution in 1991? So that's what we need to look at. So financial did 26% of 520 million. 0.26 times 520. So that is 135.2. And then we look at services, 22% of 520 million, which is 114.4. Oops, 114.4. And then we just add those together, 6, 9, 4, 2. So 249.6, but it wants our answer in the nearest $10 million. So we are going to round up to 250 million. The next data question, how many of the 6 corporate sectors listed each contributed more than 60 million to the arts in both 1988 and 1991? So I need to look at each of these sectors and who contributed more than 60 million in both years. So some that it looks like we can cross out for sure would be wholesale and possibly financial, possibly retail. But the way I would check this, definitely financial because they have 5%. And retail 8%. So we're left with services, manufacturing, and other. So I think right there we can see that they're probably services, manufacturing, and other all fit into this category. But because 17% is the smallest for these 3 industries, I'm going to just check what 17% of 630 million is, just to make sure it's more than 60 million. And let's do that in the calculator. We get 107.1. Perfect. So our answer for number 18 is 3. 3 corporate sectors. From 1988 to 1991, which corporate sector decreased its support for the arts by the greatest dollar amount? Now, I'm going to start with the answer choices here because we're looking at decreased its support, and we know already that services increased its support. Everyone else decreased. So services can get crossed off our list right away. And then manufacturing, retail, wholesale, and other, their amounts look pretty similar. It doesn't look like their support was decreased quite that much. So I'm going to focus on manufacturing and retail first and actually do the math here. So manufacturing, we have 31% 31% of 630 minus 20% of 520 is going to give us 195.3 minus 104. So that means their decrease was $91 million. And then retail, 19% of 630 minus 8% of 520 is 119.7 minus 41.6, $78.1 million. So it looks like manufacturing had the biggest decrease in support for the arts. And our final question from the data section. Of the retail sector's 1991 contribution to the arts, a quarter went to symphony orchestras and a half of the remainder went to public television. Approximately how many $1 million more did the retail sector contribute to public television that year than to symphony orchestras? So, the retail in 1991 spent 8% of 520, or $41.6 million on the arts. A quarter of that went to the symphony, which is $10.4 million, and what was left, a half of what was left. So to find what was left, we're going to do 41.6 minus 10.4, which is 31.2 million is left over, and a half of that went to public television, which is 15.6 million. And the question wants to know how many more millions more did they spend on public television than on the orchestra. So we do 15.6 minus 10.4, and we get 5.2, which is A. I think the biggest thing with the data section is really the time it takes to do a bunch of calculations. So that's the thing to watch out for. Otherwise, it's pretty much just, can you read the graph and then properly do those calculations? Okay, 21. First of all, we have another one where we could possibly have more than one correct answer. And I am going to read it. Okay, let's read it. The total number of recording titles distributed by music distributors L and M is 9,300. The number of recording titles distributed by L is 7,100. The number of recording titles distributed by M is 5,200. Which of the following statements must be true? So, first of all, I see that there is clearly an overlap, because if L and M together distribute 9,300 titles, but L distributes 7,100 and M distributes 5,200, that when we add it together is clearly going to be more than 9,300. In fact, it's 12,300. So I know there is overlap in their distribution of titles. So C is clearly going to be wrong. C says no titles are distributed by both. That's not true. There's definitely overlap. So my first step is going to be to find what that overlap is and then compare L to M. So there is a formula that's easy to use here, which is for overlap. So it looks like this. The total is L plus M minus both plus neither. So in this case, we don't have a situation where either of them don't do something or one of them don't. So neither is not going to be important here. But basically we have our total, we have each of them, and then we can solve for both. So 9,300 total is 7,100 plus 5,200. 5,200 minus x, and let's solve for x. We get 9,300 equals 12,300 minus x, so x equals 3,000. So the overlap is 3,000 titles, And I'm going to find the percentage of titles that is for L and M. So what I mean is 3,000 is what percent of L's titles, 3,000 is what percent of M's titles. And we can simply do that by doing 3,000 divided by 7,100 for L. And that is 42%. 42%. And 33,000 over 5,200 is 0.57 or 57%. And so when I look at the answers, A, more than half of the titles distributed by L are also distributed by M. No, because the overlap is only 42% there of L. But for B, more than half of the titles distributed by M are also distributed by L. That is correct because we have more than half. 57% is more than half. So our answer is B. 22. If C and D are positive integers and M is the greatest common factor of C and D, then M must be the greatest common factor of C and which of the following integers? So for this problem, I am going to try to choose numbers for C and D so that I can try to think about this less abstractly and kind of see it in front of me in a more concrete way. So let's say C is 6 and D is 21. Because I want to choose small enough numbers that I could do this math pretty easily and go from there. So the greatest common factor, M, let's solve for M. So C, the prime factorization is 3 and 2, and then 21 is 7 times 3. So our greatest common factor is 3, so M is 3, all right? Then we want to know M must also be the greatest common factor of C, which is 6, and which of the following integers. So now we can just plug in our numbers and see what we get for each one. So C plus D is 27, and the greatest common factor of 6 and 27, let's see what that is. So we know 6 is 3 and 2. Prime factorization of 27 is 9 times 3, 9 times 3. So 3, M is still 3, so M remains the greatest common factor for A, so A works. B, 2 plus D, so 23. 23 is a prime number, which means the greatest common factor is not 3 any longer, so B is not our answer. C times D, 6 times 21 is 126. So let's take 6, we're going to keep 126. Prime factorization is 2 times 63, and 63 is 9 times 7. All right, our greatest common factor of 6 and 126 is 6. So that is not M. 2 times D, 20 is 42. Again, I know already, but that the greatest common factor is going to be 6 again, because 42 divided by 6 is 7, right? So D is not our answer. And then finally, D squared, 21 times 21, is going to be so big. I mean, it's definitely going to be 6, or if there is a greatest common factor at all. So A is what we're left with, our answer. Now, the thing that's important to remember here is if you choose other numbers, like 6 and 21 didn't just come to you, it might take a little longer to work this out because there are situations where D works for this problem. So in that case, you do your first round with the first set of numbers you chose, then you would have A and D as possibilities, and then you would need to try again with a new set of numbers, trying to figure out if one of those is always true, and the one that is always true is A. Okay, another numeric entry problem. The average of the 11 numbers in a list is 14. If the average of 9 of the numbers in the list is 9, what is the average of the other 2 numbers? So let's write down what we know. The average of 11 numbers in a list is 14. So 14 equals sum over 11. That means the sum of all the numbers in the list is 14 times 11, or 154. Then the average of 9 of the numbers in the list is 9. So we can take a separate average over here. 9 equals a different sum over 9. So that other sum is 81. And what is the average of the other 2 numbers? So I know that this 81 is being taken out of the 154, and then we're left with the 2 remaining numbers. So we can do 154 minus 81 is 73 is our new sum of the 2 numbers. So we'll find our average by doing 73 divided by 2, which is 36.5, and that will be our answer. All right, we're almost done. Next one. Of the 750 participants in a professional meeting, 450 are females, and half of the female and a quarter of the male participants are less than 30 years old. If one of the participants will be randomly selected to receive a prize, what is the probability the person selected will be less than 30 years old? So we know our total is 750 people, but the probability, the numerator, so if we remember the probability formula, is the number of desired outcomes divided by the number of possible outcomes. So we know our possible outcomes are 750. We need to figure out the number of desired outcomes. And so I know I need to figure out first. We know 450 of these people are female, and a half of the female group is under 30. So we do 450 divided by 2. So 225 females are under 30, and a quarter of the male participants. So let's figure out how many male participants there are. If there are 450 female participants, then there are 300 male participants. So let's do 300 divided by 4, 75. So this is what our probability formula looks like. 225 plus 75 is 300. 300 over 750. So our fraction reduces to 2/5, and that is D. All right, and our final problem for this section. In the xy plane, what is the slope of the line whose equation is 3x minus 2y equals 8? So the nice thing about the equation of a line is all we have to do is arrange it in the right order, and we will see the slope without having to do much else. We don't need to know points or anything about the line. So I need to arrange it into the y equals mx plus b form of a line. So I am going to subtract x from both sides. Subtract 3x from both sides. And then I'm going to divide both sides by -2. So negative 3x divided by -2 is 3/2 x, and 8 divided by -2 is -4. So our slope is 3/2, and that's D. All right, and that is that. Thanks so much for watching. If you have any specific problems you'd like me to cover, please tell me down in the comments, and make sure to like and subscribe, and I'll see you in the next one. Bye! Bye-bye, bye-bye, bye-bye. Ew.